Look at this problem. Solve for x. Do you remember how to do this? Well, in this lesson 3.3, we're going to be solving log functions, and we'll walk through all the steps, all the tools you need to solve this equation for x in here with all this other stuff around it. Alright, let's get started here. Let's warm up your brains here. What is x in this problem here? 2 to the 3 power. What would that be? Let's see. We know that x is 3 because 2 times 2 times 2 is 8. Well, what if I gave you the 8? Well, from this problem, you know that 2 to the 3rd power is 8, right? What if it looks like this? Well, these two are the same, so if this was a 3, then x must be 2, because 6 divided by 2 would be 3 up here. And then what about 2 to the 6th power? 2 to the 6th power would be, well, 2 times 2 times 2 times 2 times 2 times 2, which would be 64. Okay, some good ones to remember is 2 squared is 4. You should remember that 2 to the 3rd power is 8, 2 to the 4th power is 16, and 2 to the 5th power is 32. And then once you know those basically those 5, the first 5, then you know that the next one is times 2 more. Then 32 times 2 would be 64. All right. So 2 to what power? 2 is equal to 64 to what power? Well, if you think about this carefully, we kind of have this problem backwards. So it's going to be a root, right? We're taking 64 and we're going to make it smaller with an exponent, so that has to be a fractional exponent. So it becomes a root, and that root's going to be 1/6 because 2 to the 6th power is 64. So 64 to the 1/6 power should get me back to 2. Okay, so this is actually 64 to the root of 6. Now what about 8? 8 is equal to 64 power to what exponent? Well, we know that 8 squared is 64, so we know that the square root of 64 is 8, or x is equal to 1/2. What about 2 is equal to 8 to what power? Well, from here, I know that from these two, I know that 2 to the 3rd power is 8. So 8 to what power is 2? It's 1/3. And then this last one, well, 2 to what power is 16? 2 to the 4th power is 16, so 16 to the 1/4 power will give you 2, or the 4th root. Rational exponents. If you have an exponent that's a rational number, like a fraction, this is exponent on the 9. This is the root of 9, the square root of 9. So if you take the square root of 9, you should get 3, and 3 squared is 27. Okay, so what about 2 to the 2/3 power? Well, the cube root of 8 is 2, and 2 squared is 4. About this one. Okay, remember I told you it's good to remember all the base 2's up to 5, so you should know that this is 2 to the 5th power is 32, so 2 to the 5th root, 32 to the 5th root is 2, 2 cubed is 8. And what about this one? The 4th root of 624 is 5, because 5 times 5 times 5 times 5 is 625. Then 5 to the 3rd power would be 125. What about this one? Well, before you do all that work, always try to reduce your exponent If we reduce our exponent, we get 2, which is 9 to the second power is 81. What about this one? This reduces to a half, so the square root of 9 is 3. What about this one? Well, this one's going to be 3 over 2, which is like this one here, so it will be 27. But this negative sign doesn't make anything negative. It's a little flag saying, hey, I'm in the wrong place. So you're going to have to flip this, take the reciprocal of it, flip it around, and you get 1 over 27. What about this? Power to a power rule. This would be 3 to the 1/2. Actually, you can do these in any order that you want, to the 9, to the base. So I can do the 1/2 first, because this is multiplication here. So 9, the square root of 9 is 3. 3 to the 3rd power should be 27. Okay? Or we're just multiplying these. Alright? And because multiplication, you can do them in either order, that means you can take the square root first and get 3, and then take it to the 3rd power. Alright. Change of base. Log base 3 of 6 is equal to log base 10, or the common log. As long as these two bases are the same, then you take this in the numerator and this in the denominator. Log base 10 of 6, log base 10 of 3. So the formula for it looks like this. You take a base, that's your base, and then the x goes here, and then take any log that you want. You can take a log base 3, as long as these two have the same basis here. Just like these have the same basis here. Okay. Okay, changing base using the common log. So this should be log of 25 over log of 4. Okay, that's fine. All right, so we have common log of 25 over common log of 4. And on my calculator, I get 2.32, or that's approximated 19, 4 decimal places. Okay. All right. Next, what about that one? Doing this on your calculator. See if you can get that first. I get this approximates to 3.5850, because this was a 496. In order for me to round this up, making this 50. Okay. All right, so we're good with that. Properties of logs. When you have a product, it's going to be the sum of those. And when we have a quotient, it's going to be the difference of those. And when we have a power, you just take the exponent and you put it in the front. So some examples might be, let's see, if we had log base, let's see, 3 of 7x, that would be the same as log base 3 of 7 plus the log base 3 of x. And if this is log base 3 of 7 over x, then that would be log base 3 of 7 minus the log base 3 of x. This is log base 3 of 7 to the x. That would be x times the log base 3 of 7. Okay. Okay. Let's see next. Using the property of logs. We'll do this one first. This is equal to, if I can only use 2, 3, and 10, how can I break this down into 2, 3, or 10? I can break that down into 2 times 3. That's not quite the way I wanted it. 2 times 3. So that's going to be 2 plus log of 3, like that. Okay. What about that one? This would be 27 can be written as a base of 3, right? A base of 3 to the third power, like that. So this will be log base 10 of 2 divided by 3 to the third power, which can be written as log base 10 of 2 minus the log base 10 of 3 to the third power. That's the quotient, right? The product and the quotient. And on this one, we can actually move that 3 here to the front, like that, and put that back in there. So that should really look like that. You good with that? Okay, good. And then let's see here, one more. How could you write this one here? In 2, 3, and 10s. That looks like all 10s to me, so this is really log base 10 of 10 to the third power, because it's 10 times 10 times 10, which means that I can move the 3 to the front, like that. Okay, great. And what about this one? Last one here. This can be written as, can you break this down into this for me? 2, 3s, and 10s. I think this will be 2 squared times 10 squared, which would be log base 10 of 2 to the second power plus log base 10 of 10 to the second power, moving the 2's to the front, changing exponent into a coefficient. Like that. Okay, great. Okay, now we're going to do these again. These are the same problems, except now I've given you what these are equal to. So you remember from the last slide that this is 2 times 3? Well, the log of 2 times 3 would be this plus the log of 3. So it'll be 0.3010 plus 0.4771, which will give me 0.7781. This was, remember, we had log, I'll rewrite it for you, log base 10 of 2 minus 3 times the log base 10 of 3. So that's going to be 0.3010 minus 3 times 0.4771. And then if I use my calculator to do this, 0.3010 minus 3 times 0.4771, I get a negative 1.1303. And if you remember, this was 3 times the log base 10 of 10. And log base 10 of 10 is 1. So this is just 3. And then this was 2 log base 10 of 2 plus 2 log base 10 of 10, which is 2 times 0.3010 plus 2 times 1. So this will give me 2.6020. All right, moving on. We're going to do a PERT problem and compound it continuously, right? That's how you can tell you're talking about a PERT problem. Okay, I'm going to do this problem the old way, and I'm going to show you a little shortcut because we know how to use logs now. So we have, let's see, the amount is equal to the principal times e to the interest rate, which is 0.075, and time. That's what we're trying to find. It looks like we have too many things that we don't know here to solve this, but the key here is for the amount to double. Okay, for it to double, then that means if you put in $100 for P, what would you expect to find here? And the question will be how long it would take for you to get $200 back, right? You want to double your amount. You want to know what time, how long it would take to double your amount. If you put in 100, you get 200 back. If you put in $1, you should get $2 back. If you put in 1,000, you should get 2,000 back. Well, if you divide both sides by your P, that means that the ratio of A over P, right, dividing both sides by P, that means your ratio of A over P has to equal 2 because you can double your money. So if whatever you put in, you're going to get twice as much back out. So the ratio of that has to be equal to 2. So here is my little tricky shortcut. This is the shortcut here. And you can solve it for t because it's always going to be 2 when it says it's going to double, right? And the question's always going to ask you for doubling. And if it says tripling, you would use 3, but I rarely see that question. So this will always be 2. So you're just solving for t here. Well, since it's always going to be 2, the only thing that's going to change here for doubling is the interest rate. If I can just keep this as r for a second, then I'm going to make myself a general rule. The general rule is if I take the log of both sides, okay, to get rid of the e, that means that I'm going to have the log, natural log of 2 is equal to RT. And then since I'm solving for t, I get t is equal to the natural log of 2 over r. All right? Now all we have to do is put in the r, which is 0.075. And in my calculator, I get the natural log of 2 divided by 0.075. And I get 9.24. So about 9 years. So it says amount of time, it didn't ask you for years, so that means I got 9 years. And then if I put 0.24 times 12, because there's 12 months in a year, that would be equal to about 3 months. 9 years and 3 months. Okay, so you take the 9 and you take this part right here and you multiply that by multiply this part by 12 and you should get about 3 months. Don't forget the decimal, otherwise it's not going to work. Okay, all right, great. So here's the PERT. Do the ratio, which is 2, and then you get this, and then you can simplify this more if you want. You can solve it for t, and you'll get this formula, which I just used for that. So if you see a problem like this where it asks you how long it would take to double, you will use this quick little formula here without doing all that other stuff. Plug in your interest rate, and you should get 9 years and 3 months. Alright, so now let's begin our solving problems here. We're going to solve this, and we're going to have this as x, and we know that we can use the antilog. The antilog would be the base of x. You turn both of these into exponents. These cancel. That means 81 is equal to x to the 4th power. So, I want to know what number to the 4th power would give me 81. Or I can take the 4th root of both sides and I get x is equal to the 4th root of 81 is 3, because 3 times 3 is 9 and times 3 is 27, times 3 again is 81. So the answer for this one is 3. Next. See if you can do this one on your own. Okay? Alright, I'm going to try it here. I'm going to take the antilog of both sides. And that cancels that. And I have 16 is equal to x to the 4th power. And how would you finish this? Well, 4 to what power is 16? Or you can say x is equal to 2, right? Or you can just put this in your calculator, because we already have x solved out here. Put this in your calculator, you can get the answer. You can use the change of base, set this up as log, common log of 16 over the common log of 4. And it should come out to 2. Okay. I like my way better, because if I punch this many buttons in my calculator, I have a good chance that I'll come out with something wrong. But if I do it this way, I know what 4 squared is. Okay. What about this one? If you want a challenge, go for it. Try it yourself. See what you get. Otherwise, I'm about to do it. Okay, so you're going to take the base of 3. Cancel. This is the antilog, right? Antilog. So you get 3x plus 2 is equal to 9. Subtract the 9. You get 3x is equal to 7. Divide by 3. And x is equal to 7/3. Yay. Alright, so we're going to do this one here. I'm going to take the antilog, so get square root of 3 is equal to x is equal to 3 to the x, and we know that this means the square root, and the square root is a half, so x is equal to 1/2. What about this one here? So first we're going to condense this. Okay, because you can't really take the antilog of all this, that won't work. You have to take the antilog of both sides, and you have to do it twice on this side, which is going to ruin our properties. So first we're going to condense this. We're going to say this is log base 6 of 3 minus x, which is really the quotient right? That's how we expanded this using 2 logs. And then now we can take the anti-log of both sides. Now 30 over x is equal to 8. Multiply both sides by x. Get 30 is equal to 8x. Divide by 8. And x is equal to 30 over 8, or reducing that is 15/4. Now, from here, you'll see me do this a lot with proportions. With a proportion, you can switch these two, the numerator and denominator, across the equal sign. And then that will save you a bunch of steps here. This would have been 30 over 8 is equal to x if you just switch these two. Okay, that's a little trick that I like to do. It's a math. It's actually not a math trick, but it proves that it does work when you work it all the way through like this. Okay, I believe we've come to where we started. There we go. This is the problem I gave you at the beginning. And to see if you knew, remember, now I hope that you remember. This is a little bit tricky. I'd be really, really impressed if you can work it all the way through without watching me do it. So you can give it a shot, or you, if you don't know, you can just release little parts of it and then continue. Okay. So this is sum. So that means I'm going to do a product. Now I have a log on both sides. I can do the anti-log. And I get x plus 1 times x is equal to 12. Now normally I don't like to distribute things out because it makes it worse, but we have a quadratic, and when we are trying to solve a quadratic, an x squared equation, I have to have a 0 on this side. So now I do have to FOIL this or distribute this. So this would be x squared plus x is equal to 12. And the reason I distributed that was so I can get a 0. So now I'm going to have to make that 0 by subtracting 12 from both sides. So that would give me x squared plus x minus 12 is equal to 0. This is factorable. If not, you would use the quadratic formula. And then this will be, how about a positive negative 3 and a positive 4. So that means x is equal to positive 3 and a negative 4. Did you get that? That'd be awesome. Don't forget to do the Google form. Okay, that's it.